As we begin this next unit on inequalities, we need to become familiar with the four inequality symbols. The first of those inequality symbols is the greater than symbol. The second is the less than symbol. The third symbol is greater than or equal to. This line underneath means or equal to. So a number can be greater than or equal to. And then the last symbol is less than or equal to. We will use these four symbols in the inequalities that we solve in this unit. What you'll notice is that every inequality will have one of these four symbols. Inequalities can be solved just like an equation. We will not need to learn any new steps in terms of solving a problem. We'll use all the same steps that we used when we solved equations in the last chapter. The difference in an inequality is that instead of one specific answer, like we had with an equation, there is not one exact solution in an inequality. There are many solutions to an inequality. The solution to inequality is a whole range of numbers. So for example, in an equation, I might get an answer and find out that x equals 2. But as we solve inequalities, we won't find out that x is specifically 2. We might find out that x is greater than 2, meaning x could be 3, x could be 4, x could be 5, x could be 80, x could be 102, x could be anything as long as it's greater than 2. The other big difference in an inequality is that our possible solutions are graphed on a number line. We take our answers and we graph them on a number line. So let's look at how we would do that. If I have an inequality and the answer is x is greater than 2, that means x can be anything greater than 2. So what I'm going to do is I'm going to put 2 on a number line, and I'm going to show where the numbers are that are greater than 2. As I graph, I'm going to always put a circle on the number in the answer. I'm going to use an open circle or a colored in circle. I use an open circle if my inequality symbol is a greater than symbol or a less than symbol. I will color in the circle if my symbol is greater than or equal to, or if my symbol is less than or equal to. Filling in the circle communicates that x might be that number exactly. So let's go back to number 1 over here. X is greater than 2. I am going to put an open circle on 2, and then I'm going to draw an arrow pointing at numbers bigger than 2. So that is this direction. 3, 4, 5, etc. Those are all numbers that are bigger than 2. Those are the possible values of x. So my arrow that points in that direction means anything in that direction is a possibility for x. X is less than or equal to 4. So I want to put 4 on my number line. And I want to communicate where are numbers in relationship to 4 that are less than or equal to 4. So if it could be equal to, remember our symbol over here, I said we would do a filled in circle. And then where are the numbers on a graph that are less than 4? They're back this way. So my arrow points to the left. Number 3, x is greater than or equal to -6. I'm going to plot -6 on the number line, and you don't have to draw 6 slashes. Just put 0 to separate positive and negative numbers, and put -6. Okay, where are the numbers that are greater than -6? all positive numbers are greater than negative 6. So we want all the numbers on this side. Now, since x can be equal to or greater than negative 6, we use the filled in circle. Number 4, x is less than negative 1/4. Negative 1/4 would be just beyond 0 on the negative half of our graph. X is less than negative 1/4. Numbers that are less than negative 1/4 mean we're getting smaller. So we have to be moving in this direction, away from all things positive. And we use an open circle on negative 1/4 because x cannot be exactly negative 1/4. So notice when we graph, it's important whether the circle's open or closed. An open circle simply means greater than or less than. A closed circle means greater than or equal, or less than or equal. And the arrow must go in the direction of our answers. Now, let's think in the opposite of what we just did. Let's write an inequality that would match each of these graphs. Let's take the first graph. We have a closed circle, so that means we have to use the greater than or equal or less than or equal to symbol. Our dot is on 3, so our inequality is going to be about the number 3. Does the arrow point at numbers greater than 3 or less than 3? Greater than 3, right? 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. So x is going to be something greater than or exactly equal to 3. Look at the second graph. We have a circle on negative 2. That circle's open, so that means my symbol must be less than or greater than. Which way does this arrow point? Is it pointing at numbers smaller than negative 2 or greater? We're pointing at numbers smaller, right? We're moving away from the positive numbers, so x has to be less than negative 2. Let's look at the third graph. We have a filled in circle on negative 4. So that means we have to use the or equal to part in our symbol. Are these numbers that the arrow is pointing towards greater than negative 4 or smaller? Smaller, right? Again, we're moving away from anything positive. So x is less than or equal to. And again, it's or equal to because of that circle being filled in. Now, let's look for a minute at just some basic questions about inequalities so that we can test our understanding of those inequalities. Is negative 3 a solution to the inequality below? If we look at this graph, would negative 3 be a solution? No. That arrow points at all numbers greater than 4, or because of the closed circle, equal to 4. This graph represents the inequality x is greater or equal to 4. So would negative 3 be a solution to that inequality? No. How about 4? Would 4 be a solution to this inequality? Yes, that filled in circle communicates that x might be equal to 4. Let's look at the graph on the right-hand side of the page. Would negative 3 be a solution to this inequality? Yes, notice the arrow is pointing at numbers that are smaller than negative 1.5. Negative 3 is down here. It would be a solution. Is negative 1.5 a solution to the inequality below? No. How do we know that? Because the circle above the negative 1/2 is not filled in, so x cannot be exactly negative 1/2. Now let's look at a few questions that don't have a number line. Is 8 a solution to x is greater than or equal to 6? Is 8 greater than or equal to 6? Yes, so that is a possible solution. Is negative 7 a solution to x is less than negative 5? Is negative 7 smaller than negative 5? Yes, it is. So that is a possible solution. Finally, which of the following values for x would satisfy the inequality x is less than or equal to negative 2? Let's circle all of the possible choices. Could x be 7? Is 7 less than negative 2? No. Could x equal negative 2? Is negative 2 less than or equal to negative 2? Yes, it's equal, so that's a possible solution. How about 0? Is 0 less than or equal to negative 2? No, so it is not a solution. X equals negative 6. Is negative 6 less than or equal to negative 6? Yes, so it is a possible solution. Is negative 12 less than or equal to negative 12? Yes, so it is also a possible solution. So in summary, when we graph inequalities, we have a whole range of answers. There are a lot of possible solutions that x could be. We have to stop and read the inequality, look at the symbol, and decide if the given values of x would fit in that particular inequality.